Hello everyone and welcome back to Newton's Academy past paper review for grade 12. Today we will be breaking down a mathematics past paper question on trigonometry, specifically 3D trigs. So taking a look at this question, the question reads in the diagram below, length RS is the height of a vertical tower. T and Q are 2 points in the same horizontal plane at the foot S of the tower. From point T, the angle of elevation to the top of the tower is 60. RTQ equals theta, RQT equals 60, and TQ equals K meters. And then they've drawn for us a diagram with all the angles and sides indicated that they have given us in the short paragraph. Question 10.1 asks, express TR, which is this length here, in terms of theta and K. Now, firstly, we see that TR is a common length to two triangles. It's a length which forms part of this right angle triangle, and it's a length which forms part of this triangle here, which is not a right angle triangle. Now, they wanted TR in terms of theta and K, and we see theta and K is part of this triangle, which is not a right angle triangle. Therefore, we will be using this triangle to solve for TR in terms of theta and K. So since this triangle is not a right angle triangle, that means we cannot use our normal trig ratios, sine, cos, and tan. We need to use either the sine, the cosine, or the area rule. And looking at this, we are not given the area, obviously, so we will not be using the area rule. They want TR, and we see TR, we do have the angle opposite that side, and they want it in terms of K. And the side K, we don't have the angle opposite that side, but we can find that angle through sum of angles in a triangle. So we can find this angle in terms of theta. That means we have two pairs of one side and one angle or one opposite angle each, because the angles correspond to those sides, meaning we can use our sine rule. So we will use the sine rule to solve for TR in terms of theta and K. So let us do that. 10.1. Okay, so firstly we identified this is our first pair here and here, and our second pair is TR and this angle there. So we will have TR divided by sine 60 equals, and then we have TQ or length K divided by sine, and then we know this angle here is simply 180 minus 60 minus theta. So what we are left with is TR divided by sine 60, which equals to K divided by sine, and this simplifies to 120 minus theta. And then obviously we need to make TR the subject of the formula, since they wanted the expression for TR. So therefore TR will equal to K times sine 60 divided by sine into 120 minus theta. Okay, and that is our expression for TR. We see it is in terms of K and in terms of theta. Okay, question 10.2 asks, show that RS, which is this vertical length here, is equal to 3K divided by 2 the root of 3 cos theta plus sine theta. So we have to show that RS equals to this expression. So we see that RS is part of this right angle triangle, which means we should use the simplest approach possible, which would be to use our basic trig ratio sine, cos, or tan. And we see that RS is opposite this angle that we have. So opposite, and we do not have the side TS, but we have solved for the side TR in terms of theta and K. So we can use this opposite side. We can use the hypotenuse. That means we would use our sine trig ratio to solve for RS and show that it is equal to this expression. So 10.2. So we have sine 60, and with 60 being this angle here, we have sine 60 equals RS opposite all over hypotenuse TR. Therefore, if we rearrange that formula to get RS as the subject of the formula, we then get RS equals TR sine 60. Okay, and then we can go ahead and we can substitute this expression for TR that we just solved for previously. So we now have K sine 60 divided by sine 120 minus theta, and that is multiplied by sine 60 once again. So now we have to simplify this to make it look like this here. So let us start. We have special angles. So we know that sine 60 is equal to root 3 over 2. So we can simplify that further. Let's just work out here. So that will be K multiplied by, we got sine 60 and sine 60, so that's sine 60 squared. And we said that sine 60 is the root 3 over 2. So we'll square that, and that is divided by sine 120 minus theta. But when looking at the expression that the question wants us to find, we see that it has a cosine and a sine. That means we should expand this denominator, and we can expand this using our sine compound angle, and that will give us the cos theta term in that expression. So we can expand this in terms of our compound angle, our sine compound angle. So we'll have sine 120 cos theta, and we keep the negative sign since it's a sine compound angle, and then we have cos 120 sine theta. Okay, continuing to simplify the expression, we have K multiplied by the root 3 squared becomes 3, and 2 squared becomes 4, but we'll take 4 below as our denominator. Okay, and then we still have our compound angle, but we can simplify this term sine 120 and cos 120 if we substitute that into our calculator. So what we can do then is sine 120 is root 3 over 2. Wait, okay. So root 3 over 2, and then we have cos theta plus, and we have sine, cos of 120, or not plus, but rather we have sine cos of 120 minus, but cos of 120 is negative a half. So negative a half will change that negative to a positive, and we have a half sine theta. Okay. Next step, we can take out a half as an HCF from this brackets. So we have 3K divided by 4 times a half into root 3 cos theta plus sine theta. Okay, and obviously 4 times a half is 2, so we can simplify that further to get 3K divided by 2 into root 3 cosine theta plus sine theta. And looking at this expression, we see that it is the same as the expression that they asked us to solve for. So therefore we have successfully shown that RS is equal to this expression here. Again, just to reiterate, we solve for sine 120 and cos 120 by substituting in our calculators, and cos 120 is negative a half, which gave this to be positive a half. And then here we squared this, and because 2 is a denominator, it's the same as having the brackets on the side, so therefore 2 squared is 4, and 4 would come into our denominator with the 3, with the square root of 3 squared being 3, which remains as our numerator. Okay, and that concludes question 10 on 3D trigonometry. Thank you for watching.